Hey there, this is Cristando the Great, and today we are going to graph a linear inequality. So let us read the question. It says, graph the solution set for the inequality 4x minus 3y is greater than 9 on the set of axes below. Determine if the point 1, negative 3 is in the solution set. Justify your answer. So, we begin by just looking at our linear inequality, which is 4x minus 3y is greater than 9. There's not much we could do with this linear inequality right now because we do not have y isolated. So we must do some algebraic manipulation. The first thing we're going to do is we're going to eliminate this positive 4x. The way we eliminate positive 4x is by doing the inverse operation, which is subtracting 4x on both sides. So, we have 4x. We're going to subtract 4x. We still have this minus 3y greater than 9. And then I must also subtract the 4x on this side as well. We know that 4x minus 4x is going to be a zero pair. So this is going to be eliminated, and now I bring down this negative 3y. And I still have my greater than 9 minus 4x. Now we almost have y isolated, but we still need to take care of this negative 3 here. The opposite of multiplying by negative 3 is dividing by negative 3. So that's what we're going to do to eliminate this negative 3. Negative 3 divided by negative 3 is 1, so these will be eliminated. We're going to be left with y is less than. Notice that I've flipped the inequality sign because I am dividing by a negative number. When we divide by negative numbers, this inequality sign flips around. Okay? Now I have 9 divided by negative 3. That is negative 3. Over here, I have negative 4 divided by negative 3. A negative divided by a negative is a positive, so I am going to write this as plus 4 over 3x. Now that I have y isolated, I'm all set to model this using my calculator. So if I go to my calculator and I turn it on, I know that I have y in this situation, so I'm going to go to y equals. And now I'm going to type in what I have. Negative 3 plus 4 over 3 x. And notice this use of parentheses because this contains a fraction. Now the other thing I need to tell my calculator is that this is an inequality, a less than. Right now, my calculator thinks that it's an equality, an equal to. The way we tell our calculator this is by going over and pressing left, 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 until I'm highlighted on this line here. I'm going to press enter, 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 and now I have a less than sign. These are the same symbol. So now, I'm going to press second graph to get some points that are going to be on my line. I'm going to start off with 0, negative 3. So I go to my grid, I go to 0, and then I go down to negative 3. And I have my first point. Now if I continue looking at my table, I see that there's 1 and some decimals, 2 and some decimals. I'm going to skip these decimals. I'm only going to use the whole numbers. My next point I see is 3, 1. So I'm going to go over 3, up 1. And then finally, even though 2 points determines a line, I will get one more. I'll go and take 6, 5. If I plot this point, I will go over 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5. And now I have 3 points, which is more than enough for me to make my line. So, moving over to my graph, I would take my ruler and I would line it up with my points, and now I'm all set to draw my line. So, this is going to be a special type of line because of this inequality symbol, this less than. What you need to know is if you have a less than or a greater than, your line must be dotted. But if you have a less than or equal to or a greater than or equal to, you would make a solid line, just like you're used to doing. So when we make our line, we're going to make it a dotted line or dashed. And notice how we span the entire axis. Okay. So now that I have my line, I need to include one more thing on my graph, which is the shading. I'm not sure which way to shade this, but I could ask my calculator. If I go and I press graph, my calculator is showing me to shade it below the line. So, I will go to my graph, and I will shade below the line. Now, the final part of this problem is determine if the point 1, negative 3 is in the solution set. And more importantly, justify your answer. So what I'm going to do is I'm going to plot this point 1, 3 on my graph and see where it lands. This tells me to go over 1, down 3. Now I could see that this point is in my shading. What that means is that it is a solution. So the way I justify my answer is by simply writing 1, negative 3 is a solution because it is in the shaded region. And that is all. Good luck.